Okay, so welcome, dear students. So this in this video, I'll be giving some of the tutorial problems of module 2 for the course EE307 Signals and Systems. Yeah. So what I'm planning to do is I'll take some of the previous year's university questions and I'll give the brief idea of how to solve such problems. Okay, so these are some of the questions that came in the previous year's university questions, and we will go through these questions as time permits, and we will see what is the method of solving these questions. Okay, without much further introduction, let me go to the first question. So the first question is find the Laplace transform and region of convergence of the signal x of t is equal to e raised to minus 3t u of t plus e raised to minus 2t u of t. Okay, so let me take a new page. Yeah, so the question is there in the previous page. We'll go to the next page. So let me write the signal once again. It is x of t is equal to e raised to minus 3t u of t plus e raised to minus 2t u of t. So the question is what is x of s, what is the Laplace transform, as well as the region of convergence. So from the lectures you already know there exists a region of convergence, or without region of convergence Laplace transform is not complete, and hence you must always define what is the region of convergence of the Laplace transform. Okay, so this is the signal. Now let's start with the solution. First of all, we must define what is a Laplace transform. So Laplace transform x of s equal to minus infinity to infinity x of t e raised to minus st dt. Now what is x of t here? X of t here, it is e raised to minus 3t u of t plus e raised to minus 2t u of t. So we can split the integral since there are two terms, and in both terms we have u of t. Okay, since we have u of t, we can just take it from 0 to infinity. No need to consider from minus infinity to infinity. So this is equal to integral 0 to infinity e raised to minus 3t e raised to minus st dt. So I am splitting the terms, plus integral 0 to infinity e raised to minus 2t e raised to minus st dt. Okay, so this can be written as e raised to minus 3t into e raised to minus st can be written as e raised to minus of s plus 3t. Similarly, e raised to minus 2t into e raised to minus st can be written as e raised to minus of s plus 2t. Okay, so this becomes integral 0 to infinity e raised to minus of s plus 3t plus integral 0 to infinity e raised to minus of s plus 2t. Okay, so what is the so by applying integration e raised to minus, so integration gives e raised to minus of s plus 3 into t with limits from 0 to infinity divided by minus of s plus 3 plus the second term by applying integration, it is e raised to minus of s plus 2t divided by minus of s plus 2, and applying the upper and lower limits, it is 0 to infinity. And now applying the lower and upper limits, so upper limit is infinity, so it becomes e raised to minus s plus 3 infinity minus e raised to 0, which is 1, divided by minus of s plus 3 plus the second term is e raised to minus s plus 2 infinity minus e raised to 0 divided by minus of s plus 2. Okay, so thus e raised to 0 is 1, that you know. So this is e raised to 0 is 1. Here also e raised to 0 is 1. Now coming to the first term, this term will go to 0 only if s plus 3 is greater than 0. Because if s plus 3 is greater than 0, then it becomes of the form e raised to minus infinity. So for this term, we can say the region of convergence is s plus 3 greater than 0, or we can say that real part of s is greater than minus 3. Okay, so in that case, this first term e raised to minus s plus 3 into infinity, this goes to 0. Okay, now coming to this second term, in the second term, the region of convergence is s plus 2 greater than 0. If s plus 2 is greater than 0, then the first term goes to 0 because it becomes e raised to minus infinity, and hence region of convergence for the second term is real part of s greater than minus 2. Okay. So the first term, region of convergence, is real part greater than minus 3. Second term, region of convergence is real part of s greater than minus 2. Okay. So what is the region of convergence of the whole term? So we can see that, so let me draw the s plane. So this is s plane with sigma in the real axis, j omega in the imaginary axis, and let me mark minus 2 and minus 3, which are the region of convergence. So this is minus 2 on the left side, again you have minus 3 here, and we can see that due to first term we have the region of convergence towards the right side of minus 3. So if you consider minus 3 as this, so region of convergence due to first term is the right side of minus 3, and the region of convergence due to second term is right side of minus 2. Okay, so region of convergence of due to second term is, so what is the region of convergence where both the term converges? So we can see that the region of convergence is right side of minus 2. Okay, so this is the region of convergence of both terms, and hence the region of convergence of this whole expression is, region of convergence is given by real part of s is greater than minus 2, where both the terms converges. While for the region between minus 3 and minus 2, it is not a part of region of convergence of the whole term, because the second term is not converging in that region, and hence we can take the region of convergence of the whole term as real part of s greater than minus 2. So for this particular region of convergence, both the first term, this term goes to 0, as well as this term goes to 0, and what is the final expression? It is minus 1 divided by minus s plus 3, which is nothing but 1 by s plus 3, and second term is minus 1 divided by minus s plus 2, which is 1 divided by s plus 2. So 1 divided by s plus 3 plus 1 divided by s plus 2, that you can cross multiply, and I'll write the final expression. It is this goes here, so it is s plus 2 plus s plus 3, yeah, s plus 2 plus s plus 3 divided by s plus 2 into s plus 3, which is 2s I think it is 2s plus 5 divided by s plus 3 into s plus 2. So this is the final Laplace transform of this signal, and the region of convergence is given by real part of s greater than -2. So I hope this problem is clear. Now let me go back to the previous page and to see the question. So this is done. We have seen the Laplace transform and region of convergence of this signal. Okay, now let's go to the second question. Find the unilateral. Okay, so there are two cases of Laplace transform, which is unilateral and bilateral. The only difference is the limits of integration. In bilateral, you have from -infinity to plus infinity, while in the case of unilateral, so for unilateral, x of s is given by integral 0 to infinity. Okay, if it is mentioned that you need to find the unilateral Laplace transform, you just need to take from 0 to infinity x of t e raised to minus st. Even if this is not mentioned in the given problem, u of t is there, so you just need to take from 0 to infinity anyway. So find the unilateral Laplace transform of ramp function. So it is being asked to find the unilateral Laplace transform of the ramp function r of t is equal to t into u of t, and specify the region of convergence. Okay, so let me take a new page. Yeah, so this was question 1 we have solved. Now we'll go to next question. Question 2. So the question 2 is it is given that r of t is equal to t into u of t, and you are asked to find the Laplace transform of the signal. What is capital R of s, which is the Laplace transform of this signal, and what is the region of convergence of this Laplace transform. Okay, so these two things you need to find. So we know from our experience what is the Laplace transform of t. So we know that Laplace transform of r of t, it is 1 by s square. But what is the region of convergence? Okay, that we will see. So this is not straightforward. We will try to derive the Laplace transform of r of t and find the region of convergence. Okay, so let's start solving this. Okay, so by definition, what is the Laplace transform r of s, which is the Laplace transform of unit ramp, is given by integral 0 to infinity x of t. Here x of t is r of t, which is t into u of t, so you can write it as t. So this is x of t e raised to minus st dt. Okay, so this is r of s. Now how to do this integration? So there are two terms, so you need to do integration by parts. So here you need to do integration by parts. Okay, so let me divide this into 2 so that I will get some more space in the right hand side. Okay, so integration by parts. Now what is integration by parts? So r of s equal to, integration by parts is that first term into integral of second minus integral of derivative of first into integral of second. So let's take t as the first term. So let's take t, let this t be the first term, e raised to minus st be the second term. Okay, so what is the integral 0 to infinity t into e raised to minus st dt? It is first term, which is t, first term into integral of second. So integral of second is e raised to minus st divided by minus s, and you apply the limits. The limits are from 0 to infinity. So first term into integral of second minus integral of, so integral is 0 to infinity, integral of derivative of first. What is the derivative of first term? It is 1. Derivative of t is 1. Derivative of first term into integral of second. What is integral of second term? It is e raised to minus st divided by minus s dt. Okay, so this is integration by parts. First term into integral of second minus integral of derivative of first into integral of second. So this is r of s. Okay, so now try to yeah, so for the moment we will keep the first term as such, and we'll try to integrate the second term, and then we will apply the limits together. Okay, so this r of s is taken as t into e raised to minus st divided by whole divided by minus s from limit 0 to infinity. What is the integration of e raised to minus st divided by minus s? So minus s is a constant since we are integrating with respect to t. So we can maybe we can take that outside as well. There is no issue in that. Okay, so okay, so if you take this minus outside, that's also fine. So plus integral of e raised to minus st is e raised to minus st divided by one more s will come, which is minus s square from 0 to infinity. So remember, we have taken this minus outside, so this becomes plus, and after integration it got one more minus because e raised to minus st, integration of e raised to minus st is e raised to minus st divided by minus s, and we have the limits like this. Okay, now let's try to apply the limits. It is by applying the limit, the first term is applying the upper limit of infinity. It becomes infinity into e raised to minus s infinity, that is upper term, and lower limit is minus 0 into e raised to minus 0. So it is minus 0, the whole divided by minus s, plus the second term, it is e raised to minus s infinity. So infinity into s minus e raised to 0 is 1 divided by minus s square. Okay, so let's talk about the second term first. So in the second term, this term goes to 0 if s is greater than 0. So please understand that this term goes to 0. This term goes to 0 if s is greater than 0. That means region of convergence of this second term is s greater than 0. Okay, so keep that in mind. Now let's come to the first term. So this is something critical to understand. Here you have infinity into e raised to minus s infinity. What is this value? What is this value? So this is not infinity, but rather this term, the whole term becomes 0. Okay, so one explanation is that e raised to minus s infinity goes to 0 faster than infinity. So in that way you can see that it goes to 0, or else you can try to apply the limit. Okay, so so we are just talking about the first term. So what I am saying is limit t tends to infinity, t into e raised to minus st. So if you evaluate this, it becomes infinity into 0 form, and you need to apply the L'Hospital's rule. And after applying the L'Hospital's rule, that means you can write this as limit t tends to infinity, t divided by e raised to st. Now you can apply the L'Hospital's rule. So by L'Hospital's rule, this is equal to limit t tends to infinity, 1 divided by e raised to st into s. And here also it is of the form 1 by c, 1 by infinity. Yeah. So once again you can 1 by infinity, which is nothing but 0, right? Correct. So by applying the limit, you can see that it goes to 0. So hence the first term is becomes 0. Okay, so now let's come back to the Laplace transform of t into u of t. So the first term becomes 0. Second term, it becomes minus 1 by minus s square for the region of convergence s greater than 0. So it becomes 1 divided by s square, and region of convergence is real part of s. Oh, sorry. Yeah, so region of convergence is, what is the region of convergence? A real part of s greater than 0. Okay. I think the page has been changed. What is the issue? Let me check. Okay. Okay, so the region of convergence is real part of s greater than 0. Okay, so the Laplace transform of unit ramp signal is 1 by s square, and region of convergence is real part of s greater than 0. Okay, let me go to the next question. So let me erase this from here. It was supposed to be in the previous page. Okay, good, fine. So we have solved question number 1, we have solved question number 2. Question number 3, define Laplace transform. So you can define Laplace transform and show that Laplace transform of derivative is s into, okay. So this is one of the property of a Laplace transform, and you need to prove this property. So you must go through the various properties of Laplace transform, and you must be able to prove those properties. So I am not going through the, no, I'm not going to proof of this. You can refer the textbook to see the proof. Okay, now let's go to the fourth question. Solve the differential equation x dot plus 2x equal to e raised to minus 3t x of 0 equal to 0 using Laplace transform. So let me try to take a new page. Question 3, question 4. So the question given is x dot plus 2x equal to e raised to minus 3t, and the initial condition given is x of 0 equal to 0. Okay, so how to solve this using Laplace transform? What is the solution? So what you need to do is 3 steps. So first take the Laplace transform of the differential equation, express the Laplace transform, or find the Laplace transform of x, which is x of s, and then you take the inverse Laplace transform. Okay, so 3 steps are: first find or take Laplace transform of differential equation, then you find x of s. Third, so because we need to find x of t, that's why we are asking for x of s. Then take inverse Laplace transform to find x of t. So these are the 3 steps. Okay, so let's try to do this quickly. What is the Laplace transform of the differential equation? Step 1. So Laplace transform of differential equation is s x of s minus s x of 0 plus 2 capital X of s equal to, what is the Laplace transform of e raised to minus 3t? It is 1 by s plus 3. Okay, and here it is given that the initial condition x of 0, it is 0, so you can take this term as 0. Okay, so remaining thing, s plus 2 into x of s equal to 1 by s plus 3. Now coming to step 2, what is x of s then? X of s equal to 1 by s plus 2 into s plus 3. So we have obtained x of s. Now what is the third step? Third step is you need to take the inverse Laplace transform. So x of t is equal to Laplace inverse of 1 by s plus 2 into s plus 3. Okay, so how to take the inverse Laplace transform? You can write it by as partial fraction as a by s plus 2 plus b by s plus 3. So find the residue. So you need to take the Laplace inverse of this, and you can find a and b. So I'll give the value a and b here. So a is 1 and b is minus 1 here. Okay, so this becomes 1 by s plus 2, and second term become minus 1 by s plus 3. So what is Laplace inverse? What is the Laplace inverse of 1 by s plus 2? It is e raised to minus 2t u of t minus e raised to minus 3t u of t. Straightforward. So this is the final expression of solution of this equation. Okay, so we have solved the 4 questions, and now next we will go to the part B questions.